Visual and audio feedback that reacts to player actions and in-game events is really important if you want your JavaScript games to feel good. You can, for example, attach sound and explosion animation whenever collision happens in your game. You can also use this technique to make score points float from defeated enemies or from collected items. Today we will build an easy, fun project together that combines JavaScript audio and sprite animation. When we covered all these basics of triggered event-based animations, we will build a game that will look something like this, to really put all these principles in action. This video will be beginner friendly, but if you are new to JavaScript, maybe it's a good idea to start with a quick, complete course. I like, for example, this one. Launch a Rocket, Learn JavaScript Basics the Fun Way by Rich Armstrong. You can get 30 days full access to all Skillshare classes with my link in the video description. Click the like please if you are ready to become a better JavaScript game developer today. I create a regular web page markup. In document head, I link my CSS style sheet. I create HTML5 canvas element with an ID of canvas1. We will draw on it with code. I also link my JavaScript file down here at the bottom just before the closing body tag. All I need to do in style CSS is to position my canvas element, so I target it with ID. I give it border 3 pixels solid black, position absolute, height 700 pixels, width 500 pixels, background black. Let's center it, so top 50%, left 50%, and transform translate -50%, -50%. This trick will only center elements that have position set to absolute, as we do here on line 3. Everything else will be drawn with plain vanilla JavaScript here in script.js file. I need to point JavaScript towards my canvas element, so custom variable called, for example, canvas is equal to document.getElementById canvas1. CTX, shortcut for context, is equal to canvas.getContext2D. This will instantiate object that holds all 2D drawing methods we will need today. Canvas width is 500. Canvas height is 700. Let's test if we set it up correctly by drawing a quick, simple shape. It's good to test your code as you go, makes it easier to debug. I set global canvas fill style to white. This will apply to fill of all shapes now, unless I redeclare it again and give it a different color. I call built-in fill rectangle method. I pass it coordinates 50-50, width 100 pixels and height 150 pixels. Perfect, we set it up correctly and we are drawing on canvas. Now let's make it more fun. I delete the rectangle and I create a variable called, for example, explosions. I set it equal to an empty array. Its job will be to hold all active explosion objects I create. I create them using JavaScript class. I call it, for example, explosion with a capital E. Constructor will expect X and Y coordinates coming from the outside. This is important because we want the animation to be triggered at a specific location, where the event happens. For example, we want it to animate at coordinates where two elements collided, or at coordinates of mouse click. I will pass these X and Y coordinates to the constructor whenever I want to trigger new animation and create new object using this class. It's very simple, I will show you in a minute. So on this new explosion object, give it this.x property and assign it to x that was passed as an argument on line 8 from the outside. Do the same for this.y, vertical y coordinate. This.sprite width will be width of a single frame in my sprite sheet. I calculate it by taking width of my sprite sheet and I divide it by the number of frames. In this case, my sprite sheet is 1000 pixels wide and has 5 frames. 1000 divided by 5 is 200. Height of my sprite is 179 pixels. Sometimes you get sprite sheets that are too large or too small, so you might want to scale it while still keeping the aspect ratio, relationship between width and height, to make sure the image is not stretched or squished. I declare this.width property and I set it equal to this.spritewidth from line 11 divided by 2. This.height will be this.spriteheight divided by 2. It's important to divide or multiply them by the same number to keep the same aspect ratio. By the way, for optimization, it's always better to multiply than to divide. Division operation in JavaScript is more performance expensive, so instead of dividing them by 2, I could have multiplied them times 0.5. I will bring my sprite sheet into the project. You could declare it as a global variable, but I think it's a bit cleaner to put it as a property on class, like this. this.image equals new image. This is just image class constructor and it will create new blank HTML image element. This.image src will give it source attribute and I set it to boom.png. If you want to use the same file, you can download it in the video description. This image was kindly provided by one of my favorite game artists. I will link his website in the video description as well. He has a lot of cool game art there if you are interested. To animate this sprite sheet, I will crop out one frame and I will be jumping to the right by the amount of sprite width frame by frame. To do that, I will need this.frame variable. I will set it to 0 at first. We will also need to add some behavior to this class. We do it by creating class methods. I will need one to update and one to draw my explosions. Update method will only have one job for now, to increase this.frame from line 17 by 1 for every animation loop. This.frame ++. Draw method will take values from the constructor and it will draw current frame of animation on canvas. We will use built-in HTML canvas draw image method that takes image we pass to it and it draws it. Draw image method has 3 versions with 3 or 5 or 9 arguments, depending on how much control you want over the image you are drawing. Since we are animating a sprite sheet, we will use the longest version with 9 arguments. The arguments we need to pass to it is image we want to draw, source X, source Y, source width and source height, of area you want to crop out from the source sprite sheet, and destination X, destination Y, destination width and destination height. These last 4 arguments will determine where on destination canvas you want to place that cropped out image onto. It might sound complicated, but it makes sense if you used it a couple of times. When you learn how to use draw image method and you get really comfortable with it, you will have complete control over sprite sheets you want to animate. It's really good and so useful. So now I will replace these placeholder values with actual variables we prepared inside constructor. Image we want to draw is this.image from line 15. Source X is the only one from these 9 arguments that might be a bit more complicated for beginners. To calculate current horizontal position, I need to take sprite width from line 11 and I multiply it times this.frame from line 17. As the program runs, this.frame increases inside update method on line 20. We will get frame 0, 1, 2, 3, 4, because we are multiplying sprite width times frame. Source Y is horizontal Y coordinate we want to crop out from the source. Since this sprite sheet has only one row, source Y will always be 0. Source width is this.sprite width and source height is this.sprite height from line 12. So now we told JavaScript what sprite sheet we want to draw and what area we want to crop out from it to display just one frame. Now I just simply tell it where on canvas I want to draw it. Destination X is this.x from line 9, destination Y is this.y from line 10, destination width and height is this.width and this.height from lines 13 and 14. Our class is complete. This is all we need to trigger this dust cloud animation and attach it to any event we want to. There are many events we can do here. Let's try one. I call window.addEventListener built-in JavaScript method. We will be listening for mouse click event, and in callback function that will run every time click event occurs. I will at first just draw a simple rectangle to make sure everything works. Fill rectangle expects 4 arguments, X, Y, width and height. I want this rectangle to be drawn at the current coordinates of my mouse click. To do that is easy. Callback function on event listener has access to built-in event objects. Usually we name it E or event like this, but you can name it anything you want. JavaScript knows that this argument passed to callback function on event listener refers to event object. You can put ABC here and it will still work as long as you refer to it as ABC later in the code as well. Basically here I am saying take event object with information about this click event and save it in a custom variable I call E. If I console log this E, I will get an error. Let's comment out line 29 for a second. Now, whenever I click on canvas, I get this console log that contains all information about current click event that just occurred. If I open it, I can see we have all kinds of details here. All we want is where on canvas this event happened, so we can draw our rectangle at these coordinates. I can see X and Y coordinates are down here as properties called X and Y. Now that I know the name of properties I'm looking for, I can use these values inside fillRectangle method. I want to draw it at x coordinate of current mouse click. I know that value is stored on my event object in a property called x, as we just saw. So I put e.x here and e.y. Width and height could be anything I want. I want my rectangle to be, for example, 50 times 50 pixels. I can't see anything when I click. That is because I used black background and default fill is also black. I set fill style to white color. When I click, you can see that we draw a white rectangle on canvas, but it's not being drawn under mouse. Why is that? In this case, event.x gives me value that doesn't account for this top and left margin between start of my web page and start of canvas. What I need to do is offset my coordinates to account for it. A good way to do that is to measure canvas position first. You can do this with one line of code. I create a custom variable called, for example, canvas position, and I set it equal to canvas from line 1, and I call getBoundingClientRectangle built-in method on it. getBoundingClientRectangle is a very useful built-in JavaScript method. It returns an object, providing information about the size of an element and its position relative to the viewport. I can console log my canvas position variable now, and you can see the object here. It contains bottom, left, right, and top position. On the graphics here, you can see exactly what these values represent. It also contains information about its width and height and its X and Y position. You can use this to measure any HTML element on your page. If you are offsetting something, it's really useful. I delete console log on line 7. I like to clean up after myself as I go. So if I want my white rectangle to be drawn under the current mouse position, I need to offset e.x and e.y by top and left margin between viewport and canvas. Horizontal x coordinate is e.x minus canvas position dot left. Now you can see that horizontal position is exactly under mouse. I also fix vertical position by saying e.y minus canvas position top. Perfect. You can see that rectangle is being drawn towards the right bottom from my mouse cursor. This is how rectangles work on canvas. If I want my mouse to be exactly in the middle of the rectangle, both vertically and horizontally, I need to do one more small tweak here. I offset my positions by half of width and height. My width and height is 50, so I offset x and y by minus 25. Now when I click, mouse cursor is exactly in the middle of white rectangle when I place it on canvas. I know this might be very basic for some of you, but I want beginners to be able to follow along with us. This course is for everyone. Now that we understand how to draw a simple rectangle on click, let's take it to the next level and use our custom explosion class to create sprite animation every time we click somewhere on canvas. First thing I want to do is to take this calculation that offsets and centers my horizontal and vertical positions, and I put them here in separate variables. This is just to keep my code clean and easy to read. I call them position x and position y, and I just copy this formula in there. I can't really do minus 25 here if I want to keep my code base reusable. I need to offset it inside my explosion class. I will show you in a second. I do this position y vertical formula. I remove console log on line 31, and I also delete my white rectangle. We will be drawing animated cartoon explosions now. On line 5, I have this array that will hold all my current active explosion objects. The goal is to use explosion class on line 8, and when we click, we push new object into this array from line 5. We cycle through all its frames using update method on line 20. We draw each step to display the animation, and then, when we reach the last frame, we remove the object from the array and we delete it. On line 31, inside click event listener, I take this empty explosions array from line 5 and I call push on it. Push is a built-in array method. It will take whatever we pass to it as an argument and it will push it at the end of the array. I pass it new explosion. The new keyword will find my class on line 8 and it will run its constructor to create a new object based on this class's blueprint. On line 9, I can see my constructor expects 2 arguments for x and y coordinates. This is important because we need to know where on canvas we want to create this triggered animation. Here on line 31, I just pass it position x and position y variables we calculated on lines 29 and 30. So now I have a way to add new explosion object into my array on mouse click. I will need a function to cycle through all objects in the array to update and draw them. Let's create animation loop. I will write a custom function called animate. Inside, I create a for loop that will cycle through all elements in the array. Sometimes if we click really fast in sequence, we will have many objects animating at the same time. Sometimes this array will be empty, it will have 0 elements, and this loop will be skipped. For each object in the array, we will call its update method and also its draw method. To create animation loop, I call built-in request animation frame function and I pass it animate, the name of its parent function from line 34. Now I can call animate to kick off animation loop. Awesome, this is working, kinda. We can see old frames because we are not clearing canvas, and I also need to center my animation around the cursor better. To only see the current frame, I call built-in clear rectangle method and I want to clear the entire canvas. If you look closely, you will notice we are skipping frame 0 because update method increases frame variable by 1 before we draw the first frame. I want each triggered animation to have its own timer. That way we can stagger the animation speed. On line 19, I create this.timer property and I set it to 0. On line 22, inside animation loop, I increase this.timer by 1 for each animation step. Now I can say if this.timer is divisible by 10 with a remainder of 0, this simply means run this code every 10 frames. Only when timer is divisible by 10, increase frame by 1. This will slow down the animation. Timer has to increase 10 times before frame increases once. Now we can see the initial first frame as well, and animation speed is 10 times slower than before. Let's make width and height slightly bigger on lines 14 and 15. You can see that my animation is drawn too much down from mouse cursor. Same as we did with white rectangle before, I want mouse cursor to be in the center of the animation. To do that, I can simply offset X and Y by half of width and height. I can either do it here, or I can also do it here inside draw image method. It would give us the same result. I can't offset X and Y here in my event listener, because at this point I don't know what width and height my animation is. I could hardcode some values here, but that would not be reusable. I think the cleanest way is to move this.x and this.y to go after width and height here, so that they can see these properties. And I offset them here. This.x is equal to x, which was passed as an argument on line 9, minus this.width from line 12 divided by 2. This centered my animation around the cursor horizontally, and this.y is y minus this.height divided by 2. Perfect. Right now I'm just adding more and more objects into my array. They stay there even after they stopped animating. You can see that if we console log explosions array from line 5. We are just adding more and more objects into the array every time we click. I need to find a way to remove the ones that have stopped animating. We could do object pooling here to avoid instantiating and deleting objects over and over, but I will show you how to do that in some more advanced tutorial. Today let's just do the simplest solution. On line 45, inside a for loop that runs through all objects in my explosions array, after I draw and update them, I check if this particular object has frame property more than 5. Frame property comes from line 18, and on line 24 we are increasing it to draw our animation frame by frame. Sprite has 5 frames, and we count from 0, so I know if frame property is more than 5, we played the entire animation. On line 44, if this particular object has frame property more than 5, I will remove it using built-in array splice method. Splice method just wants index of object we want to remove, so I for index, and I want to remove one object at this index, so I, 1. To make sure the next object in the array is correctly updated and animated after we removed its neighbor, we need to adjust index by -1, I minus. Because I'm console logging my array on line 36, in browser console I can see that we are correctly adding and removing objects from the array. Awesome. We have a solid infrastructure for triggered animation, and we can connect this code to collision coordinates, for example, and run this animation when 2 objects collide in our game. We can also connect it to different events and user input. It doesn't have to be a click event. To avoid code repetition, I will put this code into a separate custom function. I call, for example, createAnimation. I cut all this code and I paste it here. I call createAnimation from inside my click event. We need to pass down reference to event object to calculate coordinates, like this. Look what happens if I connect it to mouse move event. It gives us pretty cool effect. Experiments. This looks like some deep sea creature. When I move it like this, you can see that the first frame of dust cloud animation is always rotated the same way. Maybe I want to rotate it at different angle every time we create new explosion. To do that, I use built-in save and restore HTML canvas methods. Let me just write this and then I will explain what's happening. Translate will set rotation center point in this case. I want to rotate around its center, so this.x and this.y. I want each one to be rotated by a different random angle value. I create a new property on line 20 called this.angle. Circle is 360 degrees. HTML canvas rotate method expects radians, so 360 degrees is roughly 6.2 radians. This.angle will be a random number between 0 and 6.2. I pass this.angle to canvas rotate method on line 31 like this. Now it's rotating too much. It's because I translated draw in context to this.x and this.y on line 30. Then I rotate it and then I go from that point further to another this.x and this.y here. X and Y coordinates for our animation are already captured here on line 30. So on line 32 I replace this.x and this.y to 0. Think about it this way. I use translate, which would be 0.00 on canvas, to this.x and this.y. So between these save and restore calls, 0,0 is actually this.x and this.y. That's better. I also need to offset it by this.width divided by 2 and this.height divided by 2 here inside draw method. And remove it on lines 14 and 15. This is how you rotate anything on canvas. You save the current state of canvas to make sure the following changes affect only one draw call. I translate rotation center point on top of my current object I want to rotate. I rotate the entire canvas context by a random angle value. We draw our image and we restore canvas context to the original save point to make sure this translate and rotate only affects one draw call of one object. Canvas rotation is one of the more difficult concepts for beginners to understand. I spent the entire Halloween episode explaining it, so don't worry if this was too fast for you. If you want more details on how to rotate things on canvas, I will link that episode in the video description. For now, let's just move on. You can see each dust cloud is now rotated randomly, so the trail itself looks more chaotic, as every dust trail should. Let's comment out mouse move event. Now we have this nice cartoon dust cloud animation whenever we click on canvas. It's missing something. Let's give it some sound. It's really easy to attach sounds to event animations in JavaScript. I go to opengameart.org and let's click Browse and Sound Effects. I remember there was one I really liked. Here on left I will type magic in title search. Oh yes, it's this one, Magic Special Effects Pack. It contains 4 cool magic sounds. I download it and I take the one called Ice Blast. I rename it to boom.wav. For you, the path might be different if you chose different file or you placed it in a different folder. I only want to play the sound file once per animation, so in update method on line 25, I say if this.frame is equal to 0, take this.sound from line 21 and call built-in play method on it, like this. Choosing the right sound and animation speed is very important to how your game feels in the end. If you do it well, your game will be satisfying and your users will love to play it. Don't forget to click the like if you learned something new today. For more vanilla JavaScript game development and animations, check out my playlist. I will link relevant videos in the description down below. Thanks for coding with me today, hope you had fun.